Welcome back. On this tutorial, we are going to build a 90% confidence interval using Excel. So if you're having any issues using Excel and building confidence interval, you might want to stick around. So we are going to use, let's go to chapter 13, homework in MyLab from Pearson. And here is the problem. It says, pursuing an MBA is a major personal investment. Tuition and expenses associated with business school programs are costly, but the high cost comes with hopes of career advancement and high salaries. A prospective MBA student would like to examine the factors that impact starting salary upon graduation and decides to develop a model that uses program per year tuition as a predictor of starting salary. Data was collected for 37 full-time MBA programs offered at private universities. The data are stored in the accompanying table. Complete parts A through C below. Okay, so first thing before we start, let me here, I have a new sheet of Excel. Very important before you start, take a look at your data here, and you should have this data analysis. If you don't have this in Excel, you need to get that installed. Without this is not going to work. So again, check your Excel, click on data, and then check the data analysis. If you only have the analysis tool, you need to install the data analysis package. Okay, so with that said, let's go ahead and get started. We're gonna click in here to get our data, and then we're gonna copy to clipboard. We're gonna copy here, and then we're gonna go to Excel, and we're gonna paste that in here. Okay, first thing we're gonna do is we're gonna make these two a little bit wider so we have more space in here. Okay, so now we have our data, we have pasted it in here. Before we start, let me show you the formulas that we are gonna be working with. So y is our, y hat is gonna be our point estimate, and then the formula is plus minus d half of alpha. This is our standard error, and this is the square root of hi. So we're going to need this formula here, and we're also going to need this other formula here to calculate hi, which is 1 divided by the number of observation plus xi minus x bar squared divided by rssx. And I'll show you how to get that done in just a minute. So first thing we need to do is that we're going to go here and we're going to find our x, which in this case is going to equal, and that is given to us by the problem. Let's close this because we no longer need it. And it's 50,800. Okay, so our x is 50,800. Okay, now we need to find our y bar, y hat. To calculate that y hat, we're gonna need our b naught. Let me go one higher here. We're gonna need our b naught, and we're gonna need our b1, which is the intercept and the okay. So now that we have that, we're gonna use our data analysis, and what we want is we need regression. So you click regression, you click OK. So our input range, let's see here, our input range is going to be, our y range is the, y range is going to be this one here, from B2 to B38. And our x range is going to equal, we don't have to type equal here. It is from A2 to A38. Okay, so excellent, and we want to get this. I want to keep everything in one sheet, so we're gonna go here. Normally, I will go into a new worksheet, keep things separate, but in this case, we just want to keep everything together. So on your output options, click output range. At least that's what I'm doing. You don't have to do this, but we're gonna go right over here onto cell A42. Now we click OK, and that'll give us the information that we need. Here is our intercept. Here is our x variable 1. So all we gotta do is click in here. Our b naught is going to equals negative 16,269, and our b1 is going to equals 2.48. Okay, so now that I have that, I can calculate my y hat. So my y hat is going to be equal, open parentheses, and this is our b1 times our x value. We close that, and then we're gonna add the b naught, or the intercept, which in this case is a negative number, and that'll give us our y hat. Okay, simple enough, right? Now we know our y hat, so now we already have our y hat here. Now we need to progress with the formula. We need to find the t half of alpha, and that is fairly simple. If you do have Excel with the data package, we're just gonna go in here and we're gonna say t half of alpha. And to do that, we're going to type equals t dot IEMB, and this is a two-tail, so 2t, and we need to find a probability. Let me see, this is asking for a 90% confidence interval. So that means is 100 minus 90 is 10%, so that'll be 0.1. And then our degrees of freedom is going to equals our numbers of observations minus 2, because this is a two-tail. So our numbers of observation is 37. In this case, that'll be 37 minus 2, that'll be 35. And that'll give us our t half of alpha, 1.68. Okay, so we have that part of the formula. We have our y hat, we have our t half of alpha. Now we need to find our standard error. So our standard error is sy of x, and that is going to equal right over here. See, we already have it. That's simple. Okay, so we already have our y of x. Okay, so now that we have that, we need to find our square root of hi. So now, as you guys can see, that's a little bit more complicated. You can also use this formula to find the standard error, but in this case, the Excel already gives it to us, so we don't need to worry about it. So here is our hi. We're gonna need the square root of hi. Okay, so let's find our hi. Our hi is going to, looking at the formula, and this is the formula that I'm talking about here, is 1 divided by n plus xi minus the mean square divided by SSX. Okay, so let's type in here. So we need 1 divided by n. We're gonna need x1 minus our mean, which is x bar, and then we need to square that, and then we're gonna need our SSX. Okay, so 1 divided by 1, this is going to be equal 1 divided by our numbers of observations, which is 37, xi minus x bar square. So this one, we already have our xi right over here, 50,800, but we don't have the average or the mean. So again, we're gonna use the data analysis. In this case, we're gonna go over here and we're gonna use descriptive statistics. Click OK. And again, I want to keep everything in one sheet, so we're going to go right over here and we click OK, and that'll give us what we need. Here is our mean right here, 52,776. So what we're going to do here is just going to type equals, open parentheses. We have our x I minus our mean, which is right over here. Close the parentheses, and then we square that result, and that'll give us 390,000, uh, no, 3,904,576. Yes. Okay. SSX, you might be wondering how do you find SSX? It's fairly simple. To find SSX, what we're going to need to do is we need to find n minus 1, so our numbers of observation, which is 37 minus 1, close the parentheses, and then we're going to multiply that by our sample variance, which, oops, am I doing this right here? Hold on one second. Let me, oops. Okay, so SSX is going to equals n minus 1. I mean, you can just type 36, but in this case, I just got to continue to use Excel. Okay, times our standard, I'm sorry, times our sample variance. So we're going to multiply those. Okay, and that will be our SSX. So to find HI, again, look at the formula here. We have 1 divided by n. We have the denominator, we have the numerator, so we have all the information we need to find HI. Fairly simple. We're going to type in here, this is going to equals this number plus, we're going to open parentheses, and then we're going to divide this number by this number here. We're going to close the parentheses, and that'll give us our HI. Okay, so now what we need to do is find the square root of that. So type equals SQRT, and we have that number right there, and that'll give us 1.66. Okay, so I think we have all the data we need here. Let's type in here margin of error. So the margin of error is all those three numbers combined. So the margin of error, again, it's, let me go back in here for a minute. This right over here, this is our margin of error. So you have your y hat plus minus the margin of error. That's what we mean when we say that margin of error. Okay, so this is going to equals t half of alpha times our standard error times the square root of hi. Okay, this is our margin of error. Now to calculate the lower level and the upper level, all we need to do is going to type equals. This is going to be our y hat minus margin of error, and then is going to equals the y hat plus the margin of error here, and these are our values. So let's type that in here, make sure that we got it right. And we have 104,390 because it's asking us to round to the nearest dollar, and then we have 113,823. All right, let's check our answer. And it's done. Okay. Now for B, it says construct a 90% prediction interval for the starting salary upon graduation of an individual program with a per year tuition cost of $50,800. Okay, so the difference between here, we're doing a confidence interval. Now we're doing a prediction interval. And the formulas are really, really simple, really, really similar. So again, for this one, all we gotta do is what? To do the prediction interval, we need to add 1 to the square root of high. So this is gonna be a square root of 1 plus hi. Okay, so we got here is QRT equals SQRT of 1 plus high, that gives us 1.01. That will change our margin of error. We have a new margin of error now, and that is going to equal t half of alpha times the standard error times the square root of 1 plus high. And this is a new margin of error. Same thing, we have our lower and we have our upper limits. And to calculate those, we're going to type equals, and that is going to be our y hat minus our margin of error. And this is going to equals our y hat plus our margin of error here. And we have our new values. If you want, you can have Excel run that out for you. That way you don't have to be doing it. So what we gotta do is get rid of these zeros here. Okay, and then Excel does the rounding for you. So we have 80,443 and 137,770. So let's try those numbers here. 8443 and we have 137,770. Check our answers and they are correct. See, Excel did all the calculations for us. So let's take a look at the last question. It says, why is the interval in A narrower than interval on B? So why is this number narrower than this one here? You guys can see these numbers are not too far apart, right? Well, these are. So this is a confidence interval for the mean salary, while this is a prediction interval. And let's see what we have. One can predict a single observation more precisely. No, that is definitely not correct. One can estimate them more precisely, a mean more precisely than one can predict a single observation. And this is the correct answer, but let's see what C says. The estimate mean is larger. No, that's not correct. The single prediction observation is larger than the estimation mean. Let's check the answer, and that is correct. Again, using Excel makes everything so much easier. So make sure that you have your data analysis package built in, and you should be able to get this done. Okay, reach out if you have any questions. Have a good day.